All right, so we got chapter 5, 7 today. We got goal number 1. We're going to determine the future value. We're going to come up with the present value or time required to double a lump sum of money. Okay, and I have 3 formulas. The first one you should be very familiar with, I equals PRT. You guys seen that in Algebra 1 lots and lots of times. Remember, P is your principal. Okay, not principal. That's Mr. Lazinski. Principal. PLE, that's your investment, what you're putting into an account, okay? R is rate, and that's as a decimal. Make sure to move that decimal place over 2 spots to the left. T is in time, so years, so anytime you have like half a year, make sure you make that 0.5, or 6 months, make that 0.5, okay? And then I is interest earned on the account. Now, the new ones that you haven't seen before is what was called compound interest and continuous interest, okay? So compound interest, P is the same, it's principal, R is rate, T is time and years, all the same, but now we're compounding this thing a different number of times per year, so there's going to be an end value. So we have A equals P, we have A equals P times the quantity, 1 plus R over N to the NT power. And N is the number of times per year, so they might say monthly. And if they say monthly, you got to know how many months are in a year. We should know that there's 12 months in a year. They could say that it's compounded daily. So we should know there's 365 days in a year. Okay, we're going to assume it's not leap year, so just do 365. Okay. And you might see something like quarterly. That's something that's compounded quarterly. Well, there's 4 quarters in a dollar. There's 4 quarters in a year. So N would be 4. All right, so those are the different things you'll probably see. Annually would be 1, happens once a year. It's compounded once a year. Semi-annually would be twice a year. But these are the most common ones you see, okay? So P is principal, R is rate, N is the number of times per year it's compounded, T is time, and then last but not least, A is the amount that you're earning on the account. Okay? For compound interest, continuous interest, it's Pert shampoo for me. So from that song, we had a little formula that was given to you. So when we're talking about PERT, A equals PERT, that's principal times E 2.718. Okay? And that's raised to the RT power. R is your rate as a decimal, and T is time. All right? Hopefully you're not just walking around the house, you're writing this stuff down. Yeah, that's how you learn. All right, so let's put this into action. We got our formulas here. So we're going to use these two really most of the time. All right, so we're going to read the question and see what we got. Let's see if I can't get them both on here. Okay. So here we go, guys. It says on January 2nd, 2005, we're investing $2,000 was placed in an IRA account that paid 10% per year. Okay, IRA is just a retirement account. Okay, and it's compounded continuously. That's a key word there. I'll underline that. What will the IRA be worth on January 2nd, 2025? Okay. Well, right there it said compounded continuously, so I'm using the continuous interest formula. Okay. So I'm using this one, A equals P times E to the RT power. Okay, and now it's literally plugging and chugging. We got a principal. Principal is my $2,000 bucks. So I'm going to invest that $2,000. E is E, so don't make that 2.718. Use E because that's going to be an exact value. Don't use the rounded number. R is my rate. So who's got my rate? Is a decimal. What's our interest rate, y'all? You guys use your microphones, use your chat. What's my interest rate? What do you guys got? R2D2, be quiet. Interest rate, y'all. What's my rate? As a decimal. What do you got, John, Jillian, Julia, Zoe, Lydia, James? What do you guys got? What percentage are we using? Nobody knows. 10%. What's 10% as a decimal?
0.1.
All right, so 0.1 or 0.10 or 0.10, whatever you want to use. I usually just do 0.10. Move that decimal place over. Okay, so we got that from right there. And then time, got to do a little math here. It's from January 2nd, 2005 to January 2nd, 2025. That's a difference of what, 20 years? All right, so we know T is 20. So that's my T. I'm going to plug that in. And literally, I'm going to type this in just like you see it, guys. So I'm going to grab my fancy calculator. Paid all this money, might as well get it out. Make sure you know how to punch this stuff in. Okay, so I'm going to do 2,000. And then I have E. Okay. If you look next to the 4, do you see the natural log to ln? Well, if I press second ln, second natural log, that's e to a power. So I'm going to do second ln, e to the, and then I got 0.10 times 20. Okay, and it's literally plug and chug, and I press enter. So in 20 years, that $2,000 is now $14,778, and round to 2 decimal places if we're talking about money. So 0.11. We're talking about money. We're talking about ducks. Nope, bucks. $14,778.11. Okay. And there you go. Plug and chug. You gotta know what formula you're using. And once we know what formula, then it's just plug them in. Okay. At least to start. So when I take a look at the next one, any questions on number 1, ladies and gentlemen? Am I going too fast? We're okay. All right, so when I'm looking at example 2, it says find the amount of interest earned from $1,000 and that's invested at 6% compounded monthly after 2 years. So right there, it tells me how many times it's compounded in 1 year. That gives me the end value. So I go up to the one that has an end value. So it's not continuous. It's this guy right here. Okay, so I write that formula. So I've got A equals P times the quantity 1 plus R over N to the NT power. Okay, and then I plug in my investment, my amount I am investing, my P value is 1,000. So I'm putting in $1,000. 1 plus R, 6% as a decimal is 0.06, not 0.6. You got to move that decimal place over 2 spots. So I have 0.06, and N is monthly. We have to know that there's 12 months in a year. If you don't know that, that is not my fault. You got to blame mom and dad for that one. But you guys all know, hopefully, that there is 12 months in a year. If you don't know, now you know. If you don't know, now you know. And Jimmy knows that one. If he knows Tupac, he knows Biggie. Right? All right.
Yes, sir.
Yes, sir. N is 12 again. And time is over 2 years. This is 2. All right, so I pluggy chuggy. Literally type it in just like you see it. So I've got 1,000. Parentheses, guys, are above the 8 and the 9. So parentheses 1 plus 0.06 divided by 12, close it. Raise 2. Now, if you have a TI 83, make sure you're using parentheses around this product of 12 times 2, or change it to 24. Either way, whatever you want to do. I'm going to do just 12 times 2, just so you can see it works out. Press enter. And now, after 2 years, that $1,000 is now $1,127, and round to 2 decimal places. So the 9 rounds the 5 up to 6. So 1/6. So final answer, A equals $1,127.16. Makes you wonder, what happens to all these other numbers here? 9, 7, 7, 6. What happens to all those things? Oh, man. That was one of the premise of Office Space at the end. They are trying to steal money from their company. And they, if you've seen Office Space, they're taking this extra 9776, that amount, and putting it into their own account. And one of the guys got the decimal places wrong, so they ended up with like over $1 million or something in the account after just a few days or something ridiculous. It was kind of funny. But you had to be there, I guess. You had to watch Office Space. It's rated R, though. I think you got to be, 17 or 18 to watch it. All right. Ladies and gentlemen, do you have any questions on example 1 or 2? Just plugging and chugging. Let's move on to number 3 again for you clock watchers. 8th hour. We got out at 2:05, so we still got a good 13 minutes. I only got 2 more examples to do. This is where the applications of what we learned in chapter 5 come in. Okay. So the first thing I see, it says how long. Okay. So if I ask you how long it takes to get to Kojak's, you would tell me what? If I ask you how long does it take to get to your friend's house, if you're walking, you would tell me what? What are we looking for here? How long is WandaVision? How many days is that going to take? What are we looking for? How long is asking us to find what? Shout it out. What are we looking for?
Find T.
Yeah, we're looking for T. So when you see how long, I want to know time, right? How long does it take? Okay. Now, time is always in years. All right. So now that we're going to find time in years. So how long will it take for an investment to double in value if it's invested 8% per year compounded monthly? There's that word monthly again. That tells me the in value. That tells me which formula I'm using. I'm not using the PERT one. I'm using this one again. I'm using the one with the N. So I'm using A equals P times 1 plus R over N to the NT power. Okay, and we're going to be finding this T up in the exponents. Okay? Well, they didn't tell me how much I'm investing. All they did tell me is that how long does it take for the investment to double? Okay, so let's talk about double. This is where you get to decide what your P and A value are going to be. Okay, you get to decide how much do you want to invest. What do you guys want to invest here? Give me a number, an easy number. Give me an easy number to invest.
500.
$500. Okay. Well, if you choose 500, we want to double that. So A is going to be double 500, which we know is 1,000. Right? You could have said P's 100. Then A's double that, 200. Okay. You can make it whatever you want. Mr. Gotch always says, hey, I'm going to put in $1. And I want to know how long is it going to take for that $1 to turn into $2. Okay, this is the one I choose. Okay. Same idea when we're talking about triple. You might see a question is how long is it going to take to triple something? I do P equals 1 and then A equals 3. Because to triple something means to multiply it by 3. Okay. You can decide what your value is, but I'm telling you, this is the easiest. Okay. So let's say we said A was 2 and P was 1. And I need an R value. R is the invested at 8%. So we know R is 0.08. So we'll make that R 0.08. And it's compounded monthly, so I'm going to make this a 12. NT is 12T. Trying to find how long it takes. So right now I've got P is 1, so that means A is double that. That's 2. Times the quantity, 1 plus 0.08 over 12 to the 12T power. Okay? Now let's go and take the idea that maybe you chose 100 and 200. Or maybe you chose 500 and 1,000. Let's say we had 100 here and 200 here. Okay, you don't have to write this, just watch what's going to happen. I know I would have to solve for T here. So the first thing I would have to do is divide by whatever this number is. So if you said this was 100 and that's 200, I'd have to divide it over. Okay, and 200 divided by 100 goes back to 2, right? And then 100 divided by 100 is 1. You can write the 1 or not. I'm not going to. But that would take us back to this idea again, where this is Mr. Gotch's suggestion. Take P as 1 and A as 2. Okay, so no matter what you choose, the first thing you would do is divide over, okay? And you're going to get 1 and 2 anyway, so you might as well just start with that, okay? Well, here's the idea. This is where we learned in the last chapter before Christmas. We said, hey, I got to solve for this T. It's up in the exponents. It's so high I can't reach it unless I step on a log. You remember that? It's so high you can't reach it unless I step on a log, and the logs that I like the best are natural logs. So I step on a log, and now I can bring this exponent down. And if you natural log one side, you got to do it to the other side. So if you natural log this, you got to natural log the 2 as well. Okay, you guys seeing where we're going now? Questions so far? Let me know. So I've got the natural log of 2 is equal to, I brought down the 12T, and then times the natural log of 1 plus 0.08 over 12. Almost done here, guys. We got one more step, and we can plug it in, okay? So let's say I didn't have this. I want to get the T by itself. This is 12T. I would just divide by 12, right? And that gets rid of this guy here. Well, then I would still have T times this natural log. Well, we want to get rid of the natural log. And the opposite of multiplication is division. So I'm going to divide over this natural log. I don't know what that is. It's some number. I'm going to treat it like a number. Divide it over. And now this guy cancels. So now what I'm left with is this T. And now that equals natural log of 2. And then divided by 12 times the natural log of 1 plus 0.08 over 12. So now I'm going to throw that in my calc and get the approximation. We should get something that's going to take more than a year, right, to double my money. So we should get something more than 1. I should get something positive, not negative. Okay. And when I type this thing in, I'm going to put parentheses around this whole denominator. Okay, because I'm dividing by this whole thing. So I got the natural log of 2, close that parenthesis, and then I'm going to divide by parenthesis 12 natural log of 1 plus 0.08 divided by 12. Press enter, and I got a number of about 8.69 years. Okay, so it's going to take roughly just under 9 years. It's going to take 8.7 or 8.69, see what my math lab wants in terms of rounding. So it's going to take 8.69 years for me to double my money. Okay, and you'll hear me say this a lot. It takes money to make money. Okay, if I invest $1, okay, and now in 8.69 years, I'm at $2. If I invest $500, in 8.69 years, now I'm at $1,000. Okay. Well, if I invest $1 million under these same terms in 8.69 years, now I'm at $2 million. Right? Takes money to make money. The more money you guys invest, the sooner you invest it, the more money you're going to have at the end. All right. So that's my little spiel for today. All right. Once you guys get those jobs out of college, right? Don't go and buy a big old pickup truck. All right, go buy a modest car and then take that extra money that you'd be spending on that pretty red pickup truck and go invest it. All right. All right, you guys have any questions on this one? Common mistake people make. Sometimes they do natural log of 2 and they divide by parenthesis 12, natural log 1 plus. This is why you guys should be practicing right now. Make sure you're typing this in right. That's a common mistake. People forget to close the parenthesis there. People close that parenthesis, but then they divide by 12 natural log 1 plus 0.08 divided by 12. All my numbers are right, except I don't have parenthesis around that denominator. So I get some weird one with an e to the -4. Okay, that doesn't make sense. So you got to make sure that you're closing the parenthesis around the whole denominator. Okay. The other option that you guys could do is alpha y equals number 1, and that way you don't have to worry so much about your parentheses for the denominator. And you'll get that 8.69 there. All right. All right, any questions, y'all? All right, last but not least, before we get out of here, it takes about 2 minutes to do this. This is called present value formulas. So I got P equals A times the quantity, 1 plus R over N to the negative NT power. If I look at this formula and this one, they look identical, except the A and the P have been flip-flopped. And this power is now to a negative. Okay, this is anytime I'm looking for a present value. Okay, so here's the question. It says find the present value needed to earn $1,000 after 2.5 years at 6% compounded daily. Okay. Here's the idea. I'm trying to find my investment. How much do I need to invest so that after 2.5 years I have $1,000? So you have some money in your pocket and you're like, gosh, I want to buy this computer in 2.5 years and I need $1,000 for it. How much money do I need now so that I invest it so I can get that computer that costs $1,000 later? Okay, so this is where I would use my present value formulas. Okay, it's compounded daily, so I know it has an N value of 365. And now I use my formula up here that has the N in it. Notice the A and the P have been switched. I'm trying to solve for P. My final amount, I want it to be $1,000. How much do I need to invest? My rate is 6%. That's 0.06. 365. Negative 365 times T. T is 2.5 years, so 2.5 years. Okay, so this amount should be less than 1,000. What do I need to invest today to get $1,000 in 2.5 years? Let's see. I type in 1,000, parenthesis, 1 plus 0.06 divided by 365, close it. And now that's raised to the negative 365 times 2.5 power. So my present value, what I need to invest today to get $1,000 tomorrow in 2.5 years is $860.72. This is called your present value theorem. So if I invest this today under these circumstances in 2.5 years, I'm going to have $1,000. Okay. So anytime they ask you for what's the present value, these are the formulas that you're using with the negative exponents. Okay. All righty. Ladies and gentlemen, do you have any questions for me today?